I am Snehashis. I am going to talk about pulsed light technology in food processing. So when we are going to do any type of food processing, the major objective is that to inactivate the microorganisms or any other spoilage entity to ensure the food safety as well as to extend the shelf life of the food. So there are different types of means to inactivate the microorganisms. Let's take the most major conventional way is that to do the thermal treatment. What we are trying to do basically that we are trying to induce the heat treatment or heat energy within the system, and that will inactivate the microorganism. When we say that this is the microorganisms will be inactivated, microorganism has two functions. One is to ability to reproduce and ability to survive. So when we ensure that microorganism has lost his ability to survive, we must say that the microorganisms will be inactivated. The sensitivity of the reproduction of the microorganism is very high compared to the survival. So different types of thermal treatment or any other by non-thermal technology has been introduced for this microbial inactivation. One of the technology is that pulsed light technology. What does this technology do? That if we expose any type of food under the energy source of light, we use electromagnetic radiation. The normal range of electromagnetic radiation used is that 180 nanometer to 1100 nanometer. The 180 nanometer to 400 nanometer is called UV zone, 400 to 700 is called visible zone, and 700 to 1100 is called IR zone, that is the infrared. The ability to inactivate the microorganisms is the maximum in case of UV radiation. Within this UV itself, 180 to 280 nanometer is called UVC zone, 280 to 400 nanometer, 280 to 315 nanometer is called UVB zone, and 315 to 400 is called UVA zone. The lethality effect of this UVC zone is very high. So basically we are trying to generate some light source which can emit this electromagnetic radiation, specifically the UVC, and that will be absorbed by the food and it will inactivate the microorganism. So what is the basic mechanism within it? That it will inactivate or it will stop the ability of survival of that microorganism. So what is the basic cause of survival? The DNA synthesis within the system. So if by any means, if this UVC can change that reaction pathway, the microorganisms will be inactivated. The major by photo product it produces that pyrimidine dimers, specifically the thymine dimers. The more specific we can say that 5-thiamynyl 5,6-dihydrothymine. This is the spore photoproduct responsible for the inactivation or which is responsible for DNA strand, single strand and double strand breaks. So basically summing it up, that if we expose the food under a light source that is capable of UVC radiation, and the food will absorb that energy and microorganisms will be inactivated. There are two mechanisms. One is photothermal mechanism, second one is the photochemical mechanism. Photochemical is that when we produce this spore photoproduct, that is pyrimidine dimers, and photothermal is that when we apply the short wave pulses and for smaller time duration, that is the pulse width, the energy density on the microorganism surface will be very high, and that will result the thin layer conductive heating, and that the temperature gradient outside the microorganisms and inside the microorganism will be very high, and that will lead to the denaturation of the membrane protein and simultaneously microorganisms will be inactivated. So this is the basic thing. The overall principle is that if we want to apply or if we apply the light source UVC light, the wavelength is that 180 to 280 nanometer, and the food surface will be exposed under that light. The microorganisms will absorb that heat energy, as well as the photochemical mechanism will happen and microorganisms will be inactivated, and thus we can extend the shelf life of the food. Thank you.